Hello everyone. Today we'll be starting our next topic. I can't say chapter because it's a part of the same chapter, but a new concept that is dispersion. So as soon as we get any data, any statistical data, whether it's an individual series, it's a discrete or a continuous, our first instinct is always to find the mean, right? Or a median or a mode, in generally mean. And that's the reason why we say that central tendency are the averages of first order. The first thing that we find when we are given a data. Now, for example, if it so happens that there are two sections of class 11, A and B. Class section A has scored an average of 37 out of 50, and section B has scored an average of say 38 out of 50. Just because section B has just 1 mark more, it does not mean that section B has performed relatively better. No, the difference is way too less. Only because of one person, it may happen that they have got a 1 mark extra. So what we will do is here, so the actual mean is 37 and 38. Now, if it so happens that in section A, the average is 37 and the marks of the students are 32, 35, 38, 40, 42, 30, somewhere around that. But in case of section B, the average being 38, the marks are completely extreme. Like someone has got 48, someone has got 20, someone has got 45, someone has got 25. So very varied result, right? Because of which when we find out the average, the higher and the lower accumulates and gives us a middle kind of a value, that is 38. So individually, if I see, the average of section B is larger. But when I see in detail the actual marks and how they differ from the mean that we have got, we realize that section B hasn't performed good. It doesn't reflect good on the teacher because the marks of the students are extreme, right? But when it comes to section A, on an average, all the students have got a similar score, which reflects on the actual performance of the teacher. So even though section B had a higher average, a little higher average, but still section A performed better because the difference between each of the observation and the average is comparatively less than that of section B. So we say that section A has performed better. Did you understand this? Did you all understand this?
Yes, ma'am.
So what I'm saying is if this is my average value and these are my values, actual values. So these are the differences. So actual data may have been 30 and the average is say 32. So here the difference, also known as deviation, is 30 minus 32 minus 2. Here, if the answer would have been 25, then the deviation will be 25 minus 32 minus 7. So these differences are known as deviation. Deviation is difference between the actual value and mean, median from wherever you are finding out the deviation, right? So if these deviations are less, then it's a better data. If these deviations are more, then the values are more scattered, right? And it's not that good a data. And this scatteredness is what the chapter dispersion will tell us. So dispersion, after finding the average values, we find out we use dispersion to compare it on a higher, on a greater scale. And that is the reason since dispersion is found out after central tendency values, we say that dispersion are averages of second order, right? And what does it do? It helps us to find out scatteredness of the observation. That means how our data is scattered around the central tendency value. If my average is 32, then how the rest of my data are scattered around 32 is what the chapter dispersion tells us. So first point, dispersion are averages of second order. Second point, dispersion helps us to find out scatteredness of the observation. Third, it tells us how the observations are scattered around the central tendency value. In case of dispersion, we talk about deviation. What is deviation? Difference between the actual value x and whatever we are calculating it from, whether it's we are calculating from mean, median, or mode. When we are talking about dispersion, so sometimes dispersion is -2, -7, sometimes +10, +3. And if I add all the deviation and I get 0, does it mean that there is no difference? No, because since I'm adding the deviation, some are positive and some are negative, they may add among themselves and completely negligible. The difference may seem to be negligible, right? But that is not the actual case. So that's why when we are talking about dispersion, I'm only bothered with scatteredness. Whether the values are smaller than that or they're more than that, I don't care. I don't care. I'm only concerned with there is a difference. So when we are talking about dispersion, we only take absolute differences, that is absolute deviation. We don't consider the negative sign. Because if we consider the negative sign, then the scatteredness will never give you will never be shown in its true colors. So in dispersion, it is averages of second order. It helps us to find out scatteredness of the observation. It helps us to find out how the values are scattered around the central tendency values. And in dispersion, we only use absolute deviations. Now, the actual measure of dispersion is of four ways. But we first broadly classify into two types: absolute deviation as dispersion and relative dispersion. So, what is absolute dispersion? Where we are taking the raw and the original data. But when we talk about relative dispersion, we are basically converting those differences into ratios or percentages. So if you tell me your original marks, I got 37, 32, 45, 47, 50, and someone again tells me I got 38, 42, 41, 49, and so on. I may not be able to compare and tell you on and directly that, okay, this person has done better because I'm hearing original raw data. But as soon as you tell me in percentage, the first person got 82%, the second got 85%. I can straight away tell you, okay, the second one has done better because the percentage is high. So when we are taking original raw data, that is absolute dispersion, it is difficult for us to compare. But when we are talking about relative dispersion, it becomes easier for us to compare. So in case of absolute, we use raw original data. In case of relative, we convert the same thing into ratios or percentages, which makes it easier for us to compare the data, right? And since in absolute we use original data, so if the data would have been in kilogram, then my answer will also be in kilogram. If the data would have been in millimeter, my answer would have been also in millimeter. But since in relative we have converted them into ratios and percentages, so the unit of the variable completely goes away. So in case of absolute dispersion, the unit will hold. In case of relative dispersion, there is no unit. It's unit free. Till here, any doubt?
No, ma'am.
No.
The first thing, what does dispersion do? It helps us to find out scatteredness. Second, it helps us to find out how the values will be revolving around the central tendency value. So we can calculate dispersion from mean, median, mode, anything. In dispersion, we are mainly concerned about differences, also known as deviation. And in dispersion, we'll only be using absolute deviation, no negative signs are allowed. Next, in dispersion, it is broadly classified into two types, absolute and relative. In absolute, we use raw or the original data. In relative, we convert them into ratios and percentages. Absolute does have the unit, relative does not have a unit. Absolute does not allow comparison, relative allows comparison. The actual type of dispersion, the actual dispersion is absolute. Relative, we have found out an extra thing for us, for our benefit. It wasn't actually a variety of dispersion, right? So there are four major types of absolute dispersion or dispersion: range, mean deviation, differences between means, third, quartile deviation, and fourth, the most important one being standard deviation. So there are four absolute measures of dispersion: range, mean deviation, quartile deviation, standard deviation. When we convert each one of them into ratios or percentages, we get relative dispersion. So relative dispersion is for range, we have coefficient of range. For mean deviation, we have coefficient of mean deviation. For quartile deviation, we have coefficient of quartile deviation. For standard deviation, we have coefficient of variance. I'll explain you why the word change, right? Let's write down till here first. Heading is dispersion. First point. Central tendency are averages of first order, whereas dispersion are averages of second order. Second, dispersion measures scatteredness of observation. Third, dispersion tells us how the observations are scattered around the central tendency values. So it can be obtained from mean, median, mode, any which way. Dispersion can never be negative. In the entire chapter, you will never have negative answer. You can't. Can never have negative answers. Dispersion only uses absolute deviations. Basically, I don't want to have the negative sign. In some cases, I'll even square it. So if I'm squaring it, automatically the negative sign is removed. So there's no problem with that. Two times. Did you complete this? Done? Tilya?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So absolute dispersion and relative dispersion. Number one, uses original raw data, converts the data into ratios and percentages. We will be talking about percentage into ratios and percentages. Contains unit of measurement, it is unit free. It is unit free. Third, does not facilitate comparison, heads in comparison. Four types: range, mean deviation, quartile deviation, standard deviation. Four types. Coefficient of range. Coefficient of mean deviation. Coefficient of quartile deviation. Coefficient of variance. Coefficient of variance. So we'll be talking about four. See, range and quartile deviation is pretty easy if you know quartile. I hope you all remember how to calculate quartiles.
Yes, ma'am.
Yes, ma'am.
Done?
Yes, ma'am.
The first one is range. Range is basically difference between the largest observation minus the smallest and smallest observation. So we talk about range in so many ways. What's your price range? That means from where minimum to maximum, what is the value that you are ready to spend? Weather forecast, the minimum and the maximum is given. That's your weather forecasting range, right? So in range, we talk about only the extreme values, largest minus smallest. I'm not bothered with what is going on in between. So it is not a good data because it may so happen that one of the student may be ill, did not write the exam, got zero, and one of the student is an extreme genius category and got 100 on 100. So the range will be 100 minus 0, 100. But it may so happen that rest of the students have all got 70, 75, 80, 82 and all those. So the range should have been way less. But just because of one student, the range is increased to so. So range never uses all the data. It is only concerned with the smallest and the largest, and that's why it is never an appropriate measure of dispersion. We only use this in weather forecasting and quality change. That's it. If I want to find coefficient of range, this will be L minus S by L plus S into 100. So again, we'll be talking about all the three series, individual, discrete, and continuous. For all the three, we'll be calculating range. So for individual series, suppose data is 2, 3, 1, 4, 5, 7, 9. So what will be range?
44 months. I mean,
The
78.
largest observation is 9, the smallest is 1. The range will be 8,
Yes, ma'am.
and a coefficient of range. L minus S by L plus S into 100. So 9 minus 1 by 9 plus 1 into 100. Answer is 80%. Yes.
Yes, ma'am.
Yes, ma'am.
When it comes to discrete series, very similar. 5, 6, 7, 8, 9. Frequency 2, 3, 1, 4, 5. So highest possible value
9, ma'am.
9 and the smallest is 5. So range is 4. Coefficient of range. Nine minus 5 by 9 plus 5 into 100. Answer
28.5.
28.57.
Yes, ma'am.
28.57.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Then comes continuous. Remember, for continuous, it is necessary for the data to be a relay race. So if the data is directly 0 to 10, 10 to 20, 20 to 30, with frequencies 3 to 5, range. What is the maximum possible value? 30. The minimum possible value? 0. Range will be 30 minus 0, 30. And coefficient of range, 30 minus 0 by 30 plus 0 into 100, which makes it 100. Clear?
Yes, ma'am. Yes, ma'am.
But if the data is relay race, 10 to 19, 20 to 29, 30 to 39, and the frequency is 314, we need to first convert it into boundaries. So how do we write that?
9.5 to 19.4, 19.5.
Perfect. 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5. So now in this case, our range will be highest possibility minus the lowest possibility. 39.5 minus 9.5 is 30, and coefficient of range will be L minus F by L plus F into 100. And
61.22.
rest of you,
61.2.
perfect. Any doubt?
Ma'am. Ma'am.
Now, properties. Is it based on all the observations?
No, ma'am.
No, it is not based on all observations. Now, like central tendency, mean, median, mode, all the three had the same property, the linear relationship. If you add something and you multiply something, everything matters. In the entire dispersion chapter, if you add or subtract something, it won't matter. But if you multiply and divide something, it matters. So this range is unaffected by change of origin, but affected by change of scale. Meaning, if y is equal to a plus bx, then range of y. If you have added something, it gets vanished. The only thing that will remain is if you are multiplying or dividing something. So x is multiplied by b, so only that remains. Anything that you may have added or subtracted, that goes away. But since the answer can't be negative, in dispersion, we write absolute value. What do I mean? If y is 2 minus 3x, then range of y will be 3 into range of x. Understood?
Could you please tell again?
Suppose if I have y is equal to 5 plus 2x divided by 3. Whatever you add or subtract, that does not matter. That gets vanished. Only thing that will remain is what you have multiplied or divided. So x got multiplied by 2 and divided by 3. Those two will remain. Rest adding 5 gets vanished. So if I tell you that range of x is 10, then in this case, range of y will be 3 into 10, 30 straight. Here, if I tell you range of x is 6, then Range of y will be 2 by 3 into 6, that is 4. Understood?
Yes, ma'am. Thank you.
Third, it is used in quality control. No mathematical trick. It is not an ideal measure because it doesn't even use majority of the data. Any problem?
No, ma'am.
No, ma'am.
No, ma'am.
Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then comes quartile deviation. Quartile deviation is also known as semi-interquartile range. So we just talked about range. What is range?
Difference between largest and smallest range.
Now, if I'm saying a range between interquartile range means what? Range between the quartiles. How many quartiles are there? How many quartiles are there?
Mm-hmm.
Q1, Q2, and Q3. Out of that, which one is the largest?
Q3,
Q3, and which one is the smallest?
Q1,
Q.
Yeah, Q.
Q1,
Q1. So if I want to find out interquartile range, so range is largest minus smallest. Between the quartiles, the largest is Q3, the smallest is Q1. Yes?
Yes.
If I want to find quartile deviation, also known as semi-interquartile range. So semi means half. So half of the range is known as quartile deviation. Half of the range is known as quartile deviation. And then coefficient of quartile deviation. This is Q3 minus Q1 upon Q3 plus Q1 into 100. Into 100. Now, the main thing is here is knowing how to find quartile. So if I have an individual series, so question is 200, 210, 208, 160, 220, 250, 300. For us to find quartile, what is the first step? We have to arrange the data in ascending order, otherwise we can't even find quartiles. So 160, 200, 208, 210, 220, 250, and 300. First is arranging the data. Since it is an individual series, Q1, the formula was n plus 1 by 4th observation. So in total 7. So 7 plus 1 by 4, that is second observation. Which is my second observation? 200. So Q1 will be 200. To find Q3, it is 3 into n plus 1 by 4th observation. So 3 into 2, that is 6th observation. Which one is my 6th observation? 250.
yes, ma'am.
So if I want to find interquartile range, that is Q3 minus Q1, that will be 50. If I want to find quartile deviation, it is Q3 minus Q1 by 2, that is 25. If I want to find coefficient of quartile deviation, it is Q3 minus Q1 upon Q3 plus Q1 into 100. So 50 divided by 450 into 100. Answer?
11.11.
11.1.
Understood?
Yes, ma'am.
This is for individual series. If it is discrete, the formula remains the same. The pattern changes a little. Again, here it is necessary to arrange the data in ascending order. 153, 155, 57, 59, 61, 63, 65, 67, 169. Frequency 25, 21, 28, 20, 18, 24, 22, 18, 23. Sum of the frequency. Find out cumulative frequency. Whenever we are finding quartile, we will need cumulative frequency. 25 plus 46 plus 74 plus 94 plus 112, 136, 158, 176, 199. So Q1 was n plus 1 by fourth observation. So 50th observation. Which one is the 50th observation?
157.
So we see the cumulative frequency just more than 50, which is here. So the value of x will be known as Q1, that is 157. When we are finding Q3, it is 3 into n plus 1 by fourth observation. That is 150th observation. Which one is 150th observation?
165.
This number. So this will be 165. So if you ask me interquartile range, this is Q3 minus Q1. Answer
8.
A. If you ask me quartile deviation, it is half of this 4. And if you ask me coefficient of quartile deviation, it was Q3 minus Q1 upon Q3 plus Q1 into 100. Answer
2.48.
2.48.
done.
Yes,
Yes,
ma'am.
ma'am.
Third is continuous. For continuous, we do like median. Again, remember the interval has to be exclusive. 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Frequency 3, 9, 15, 23, 30, 20. Find cumulative frequency. Cumulative frequency 3,
12, 27.
27, 50, 80, and 100. So for Q1, we first calculate n by 4, that is 25. So this is Q1 class. So Q1 will be L plus n by 4 minus previous CF by F 15 into H is 5. How much?
14.33.
Then we calculate 3n by 4, that is 75 for Q3. So this is Q3 class. This is L, this is F, this is CF. Q3 will be L plus 3n by 475 previous cumulative frequency by frequency into H. Answer.
$23.33.
How much?
24.16.
24.17.
24.16.
16, it's larger, no? So approximating it is 17. So interquartile range. Q3 minus Q1. Answer.
$9.84.
Quartile deviation is Q3 minus Q1 by 2.
4.92.
And then coefficient of quartile deviation Q3 minus Q1 by Q3 plus Q1 into 100. 9.84 divided by 38.5 into 100.
25.55.
Sorry,
25.5.
all of you got the answer?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Any
Yes.
problem?
No,
No,
ma'am.
ma'am.
So basically when we are finding out quartile deviation and all, the only thing that we need is to know how to find quartile. Once we know that, there's nothing more to do it. Yes or no?
Yes, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
Okay then.